Selection sort, the algorithm you already understand. Strip away the jargon and sorting becomes a natural human instinct. Selection sort is just find the thinnest book, place it, repeat. Algorithms are often perceived as intimidating constructs reserved for computer science lectures, yet the reality is that many foundational techniques mirror everyday decision-making.
The visual approach to teaching selection sort demystifies this process by translating abstract array operations into an intuitive physical task, searching a cluttered desk for the thinnest book, putting it into position, and ignoring it forever. This method reframes sorting not as a mathematical puzzle, but as a predictable, repeatable behavior that anyone can internalize before ever reading a line of code.
The urgency lies in how modern developer education often leaps straight into big O formulas without grounding learners in the underlying logic, creating a barrier that visual explanations can dismantle.
The quiet revolution in algorithm pedagogy. Why visual-first learning matters now more than ever in a world of rapidly growing code bases and AI-assisted development. Current programming tutorials Chinese letter towards either treating algorithms as black boxes or drowning beginners in asymptotic complexity notation before they can see why sorting works.
This disconnect is especially acute in the JavaScript and TypeScript ecosystem, where frameworks like React and Vue abstract state management, but still rely on fundamental sorting operations behind the scenes. Selection sorts on2 time complexity might seem inefficient, yet understanding its inner loop, scanning the unsorted region, tracking a running minimum provides a transferable mental model for harder algorithms like quicksort.
The visual technique of splitting the array into sorted and unsorted zones aligns with how modern debuggers display data, bridging the gap between conceptual understanding and actual code execution. Developers who cannot visualize the sorting process often struggle to optimize real-world performance, making visual pedagogy a strategic lever for building stronger engineering intuition.
Code as narrative. Deconstructing the selection sort implementation. The two-loop structure is not a riddle, it is a choreography where the outer loop claims fixed positions and the inner loop hunts for the smallest survivor. The implementation shared in the article reveals a clean JavaScript pattern that mirrors the visual metaphor. Boundary marks the frontier between the sorted and unsorted regions, while cursor scans forward to locate the minimum element.
This separation of concerns outer loop for placement, inner loop for discovery, is a microcosm of more complex search and swap algorithms. The use of a destructuring swap result boundary, result smallest index equals result smallest index, result boundary highlights modern ES6 syntax while keeping the logic transparent.
By logging each round's transformation, the visualizer transforms abstract code into a timeline of state changes, which is exactly how developers reason about edge cases and performance bottlenecks. The critical insight is that the inner loop's conditional update if result cursor result smallest index is the same mechanism used in more sophisticated algorithms like Dijkstra's, a foundational pattern that rewards early mastery.
The verdict: visual sorting as a gateway to algorithmic literacy. As AI tools generate increasingly complex code, the ability to mentally simulate an algorithm's behavior becomes a non-negotiable skill. Selection sort's visual simplicity is the ideal starting point. The long-term implication is that teaching sorting through physical analogies does more than improve rote memorization. It builds an intuitive runtime model that scales to bigger algorithms.
For JavaScript developers working with large datasets or library internals, visualizing selection sort trains the brain to anticipate on2 bloats long before profiling tools flag them. In the broader context of AI-assisted development, where copilots generate code that often contains suboptimal patterns, a developer who can walk through a sorting loop gains the confidence to override or refactor those suggestions.
The next step is to extend this visual framework to divide and conquer strategies, merge, sort, quicksort, and to embed these metaphors directly into interactive coding environments. Ultimately, select and sort is not just a learning toy, it is the Rosetta Stone that deciphers how algorithms translate human intuition into machine logic.